There is a galaxy sitting at the edge of the observable universe that has broken nearly every rule astronomers thought they understood about how galaxies form. It is not a small violation. It is not a footnote. It is a full-scale contradiction of the standard model of cosmic evolution, and the more closely scientists look at it, the more unsettling it becomes. The galaxy is called JADES-GS-Z14-0. It was discovered using the James Webb Space Telescope, and when the data came back, the team spent weeks convinced something had gone wrong with their instruments. Nothing in their models said a galaxy like this should be sitting where it is, doing what it is doing, at the age it is doing it. To understand why this matters, you need a basic picture of how the universe is supposed to work. After the Big Bang, the universe was a hot, dense soup of particles. For the first few 100 million years, there were no stars, no galaxies, no structure of any kind. This period is called the Cosmic Dark Ages. Slowly, gravity began pulling hydrogen and helium together into the first clumps of matter. Those clumps collapsed into the first stars, which were enormous, burning hot, and short-lived. When they died, they seeded the surrounding gas with heavier elements. Over millions of years, those enriched clouds collapsed into new stars, and those stars gathered into the first primitive galaxies. This process takes time, a lot of it. Building a galaxy massive enough to be detectable, luminous enough to shine across billions of light years, and chemically complex enough to contain the signatures of multiple stellar generations. That takes hundreds of millions of years at the absolute minimum, probably longer. The universe is 13.8 billion years old. JADES-GS-Z14-0 is being observed as it existed just 290 million years after the Big Bang. That is not a lot of runway. That is an almost insultingly short amount of time for the universe to have produced what the Webb telescope is showing us. The galaxy contains more than 500 million solar masses worth of stars. Let that number sit for a moment. 500 million suns worth of stellar material, assembled and burning within the first 2% of the universe's current age. The models say that is not supposed to be possible. The raw ingredients simply should not have had enough time to collapse, ignite, and accumulate at that scale. But the mass is not even the most alarming part. When astronomers analyze the light from DES-GS-Z14-0, they found something that genuinely stopped them cold. The galaxy's spectrum showed clear signatures of oxygen, not just hydrogen and helium, which are the original elements from the Big Bang. Oxygen, a heavy element that can only be produced inside stars through nuclear fusion, and then ejected into the surrounding environment when those stars die. For oxygen to be detectable in a galaxy this young, that galaxy would have needed to go through at least one full cycle, maybe several, of star formation, stellar evolution, and stellar death, all before the universe had even reached its 300 millionth birthday. You need stars to make oxygen. You need those stars to live and die. And you need new stars to form out of the enriched debris. That entire sequence, compressed into a cosmological eye blink. The research team, led by Stefano Carniani and Kevin Hainline, as part of the JADES collaboration, the JWST Advanced Deep Extragalactic Survey, published their findings in 2024. The reaction from the broader scientific community was not dismissal. It was something closer to quiet alarm. Here were researchers who had dedicated their careers to understanding early galaxy formation, and they were looking at data that their own best theories could not explain. The standard cosmological model, known as Lambda-CDM, describes a universe where structure builds up gradually over time. Small things form first, then merge into larger things. Dark matter halos attract gas, gas cools and collapses, stars form, galaxies grow. It is a model that has survived decades of observational testing. It correctly predicted the large-scale structure of the universe, the distribution of galaxies across cosmic time, the faint temperature fluctuations in the cosmic microwave background. It works extraordinarily well. Except now, it is failing, and it is not failing quietly. JADES-GS-Z 14-0 is not a unique case. Since Webb began returning science data, astronomers have found a growing population of galaxies in the early universe that are too massive, too bright, and too chemically evolved for Lambda-CDM to comfortably accommodate. These are being called impossible galaxies in the popular press, and while that term is a bit dramatic, the underlying frustration is real. The models need adjustment. The only debate is how large that adjustment has to be. Some researchers have proposed that the first stars were even more massive and more efficient than current models assume. If early stars were routinely tens of thousands of times more massive than the Sun, they would have lived fast, died young, and enriched their environments with heavy elements on a much shorter timescale. This could potentially explain the oxygen signatures. The problem is that this explanation requires a generation of stars that no one has directly observed and that some physicists consider physically implausible for different reasons. Other researchers have suggested that the very early universe experienced bursts of star formation far more intense than anything we see in the modern cosmos. These bursts, sometimes called starbursts, are known to exist today in galaxies undergoing mergers or other violent events. If the early universe routinely triggered these extreme episodes, galaxies might have assembled their stellar populations in rapid pulses rather than the slow, steady build that standard models describe. This is a more conservative fix, but it still requires revising assumptions that have been considered well-established for a generation of cosmologists. There is also a more radical possibility that a small number of physicists have begun to take seriously. What if the standard model's treatment of dark matter is not quite right? Dark matter is the invisible scaffolding that Lambda-CDM says drives galaxy formation. Its behavior in the early universe determines how quickly structure can build up. If dark matter interacts with ordinary matter even slightly differently than assumed, or if it has properties that cause it to clump more efficiently in the early universe, then the formation timescales could be compressed in ways that would allow a galaxy like JADES-GS-Z 14-0 to exist within the current framework. This is speculative, but it is not idle speculation. It is the kind of idea that gets written up in peer-reviewed journals when the observational data stops fitting the standard picture. What makes this moment genuinely exciting and genuinely unsettling is that the Webb telescope is only getting started. JADES-GS-Z 14-0 was found in relatively early observations. The telescope has decades of science ahead of it, and with every new deep field image, with every new spectrographic survey of the early universe, the catalog of anomalous early galaxies is growing. If the current trend continues, astronomers will be forced to do something the field has not had to do in a long time: substantially rewrite the story of how the universe built its first large structures. There is a long tradition in cosmology of the universe proving smarter than the people trying to model it. The discovery that the universe's expansion is accelerating, attributed to dark energy, a thing that no one fully understands, was a similar rupture. The observations came first. The theory struggled to keep up. Physicists eventually incorporated dark energy into the standard model, but the honest answer about what it actually is remains unsatisfying to this day. JADES-GS-Z14-0 may be the beginning of a similar reckoning. Not the death of the current model, but a forced evolution of it. A signal from the edge of the observable universe, sent 13.5 billion years ago, arriving now to tell us that we do not understand the early cosmos as well as we thought. The universe was already building things that should not have been possible, in places that should not have been ready, faster than the rules said it was allowed to. And we are only now beginning to hear what it has been trying to tell us.